Hi friends, this is a course on risk conscious operational management of complex engineering systems, and we are in fourth week, that is module 4 and lecture number 3 on risk model for risk conscious culture. When I say RCC means risk conscious culture. Okay, I am Professor Prabhakar V. Vardhe, and we will get back to our subject. First, let me introduce you the what are the risk components or risk considerations in risk conscious culture. Now I am using the abbreviation for risk conscious culture. Please remember, and it is RCC. RCC employs risk based engineering, and this risk based engineering is little enhanced. Now what enhancement we have done, we will see, but then as we develop any field, slowly learning lessons are there on how to do the same thing in a better way. So in fundamental risk based engineering there was something, and we are trying to enhance this subject. So enhanced framework is there. This requires a adoption. First thing is, this requires an adoption of, we saw in the second lecture on dependability engineering, but then we know that reliability, availability, maintainability and safety, they are collectively called as RAMS paradigm. So one is dependability paradigm and other one is RAMS paradigm. They are almost simple with minor changes. So we can say essentially they are talking about RAMS only, even in dependability, how to achieve dependability as far as the operating fields are concerned. But then in this lecture, we will argue out the one enhancement. Why not we use an integrated risk paradigm, which is the integrated risk based engineering, in a manner that is all the aspects like reliability, availability, maintainability. That means all the three aspects they are addressed, and of course safety when we say, then risk. So all the four under one umbrella, and how we do that we will talk about it. And then consideration of procedural element to ensure quality consideration. The procedures are developed, they are reviewed in the plant, because procedures are a very important entity in the plant which connects the plant management with the operating staff. Because these are the approved procedures which are which require even regulatory approval sometimes, and that's why they are called approved procedures. And they get to the plant, and of course as the new knowledge comes, then these procedures are also reviewed, like some modifications you do in the plant, or some enhancement has to be done, was done in the plant. So procedures are also reviewed periodically. So to keep with the as built, as operated condition and culture of the plant. Consideration of, then characterization of operational precursor. It's a very powerful term I am introducing here, precursor. In simple word, precursors are those signatures which give us a warning that there is a failure or there is a degradation which is happening in the process, which can have undesirable consequences. So precursors are always used in terms, at least in risk engineering, in a negative sense. That means precursors to failure. Okay. So what are the signs that were available? Like suppose if a certain pipeline is having vibration 3 meters per second, but over a period of time the vibration increases. That means there are some structural issues in the pipeline. So before the failure occurs, so the vibration level, increase in vibration levels, they are precursor signatures, and plant have to take action. If we don't take action, there will be failure in the plant. It could be structural, it could have undesirable consequences also, it could be local, or it could be even at plant level also. RCC model can be adopted. Again, we are basically focusing our discussion on safety, that is random failure. But then it can be extended to security and industrial safety also. It is open with little modification or additional work, it can be adopted easily. So, and RCC culture, risk conscious culture is more important to industrial system, because fatalities, whether if you see industrial or societal system, on road accidents, railway accidents, the way it happens, lot of lives are there on the risk actually, So it is required at all the level, and it can easily be adopted. Role of enhanced risk-based engineering in RC. What is its role? Risk oblique safety is a conventionally considered as independent metrics. Risk and safety, even I can use this argument for RAM also. Reliability, availability, maintainability, safety, they are independent terms actually. So are they independent, or they are interwoven? If from the cultural point of view, or even from operational point of view, they are not as independent as we think. That's why the RAMS thing has come. Reliability, availability. There are two problems with the RAM. One is that it is considered as totally independent, number one, and safety is put at the end. To risk-based engineering, the safety is the overriding factor, so safety should come first. So they are not independent. We'll discuss how they are not independent. But if I develop a risk model, you will be pretty confident that in the fundamental of risk model is basically from unavailability of the component, whether it is a demand unavailability or it is a maintenance unavailability, it is there. Then you will know that reliability plays a huge role, not only for delivering the throughput or output from the plant. They put transient into the system. So after the transient, whether the plant will come to the safe state, 99.999% is correct. But introducing a transient in the smooth operating plant is a different dimension. So it is, even reliability can affect, and for risk modeling, the initiating events are one of the inherent component of risk modeling, and that is where the reliability of the initiating events, they come into the picture, how frequently it happens. Some event could be of severe nature, some could be simple, no consequences. So let us discuss it by giving examples. Like let us understand the following argument: risk versus reliability, availability and maintainability. This is the first heading we are discussing. Under this heading, we have following arguments. Initiating events are the part and parcel of risk analysis. So that means if the plant trips or shut down due to some transients, then reliability, it has come, because reliability is all about mission. So it is not met its mission. Okay, if it is a 1 year mission, 6 month mission, it is not met. So it is affected on reliability. So that component came into it. Once the plant trips or shutdowns, it takes time to start. Not always that immediately it will be started back. You have to take corrective action, and whether small time to 1 hour to 15 minutes to half an hour to 2 hours, it might take sometimes even days also. And if it is accident scenario, then so unavailability is better contribution is coming from tripping also. Now, for success of a system and component, reliable operation is a term. Reliability is coming into unavailability term also. How it is coming? If a safety pump has to start and deliver the safe output, then it is not, starting is not sufficient. It has to operate for a mission, and mission has got a reliability component. So we should have a reliable component So that was part of risk modeling. Then risk modeling is based on availability of plant, safety and component. We discussed that mostly it is a demand failure probability or unavailability due to maintenance, repair and testing and all that. So those things also form part of the risk modeling, because component unavailability statement is input to the risk model. Okay. So now unavailability is interpreted as demand failure probability. Now demand failure probability can be a probability. It can be taken as probability. But when I take this as in our dynamic scenario, I have to use it failure rate. Okay, and then for how much time, because that component remain in passive condition or in a latent condition in failed state. So we take half lambda t is it is an assessment of demand failure probability. So there also we have reliability component attached here. So what I am trying to argue is that if we do risk analysis, a huge part of this RAM paradigm is taken care of. Only there is a residual component which can be seen in the context of what kind of coverage we had over here. Now second part is we expand boundary. Now we say reliability and safety or risk, but then if we go out of our boundary, the power failure from a nuclear power plant or for any other plant, it has disrupted many services outside. So it has got a risk connotation. On road, accident can happen. In a hospital, the treatment get interrupted if the on-site things don't come in time and all. And then we have healthcare system, financial losses that happens. So these are all paradigm of risk actually. Other societies like cosmetic structural systems, they might fail. So what we are saying is, in our domain of plant, what we defined, it has got a reliability connotation. But when we go out of the plant, it has got a risk connotation. So every transient in the plant has got a risk connotation, not within the plant boundary, but it is outside. So so this requires that risk paradigm should be an integrated paradigm should be used, and that is perceived in enhanced risk based engineering, because this was a additional learning that happened. Why not consider the point we are trying to make as risk as single matrix where unreliability, unavailability and unmaintainability aspects form part of risk matrix. And then we can say residual and gross RAM aspect can be handled separately. If it is not important to risk, they may not be all that important also. So, but then yes, we can show what are the parts have been covered, and that residual component, pretty sure that it will be very small component. Now, adoption of risk-based engineering, even though the framework remains as it is, but when we execute the procedure of data collection, seeing how integrated it is there in the actually, so at every module it affects, So let's take integrated approach. Deterministic approach, what we had initially, has now got component of uncertainty in the form of best estimate approach. So if we have best estimate approach, here we have probabilistic consideration for uncertainty. So these two together, they get converted into a enhanced model. Okay. Now risk, goal and criteria. Possibility of moving from 3 sigma. Okay, we have a culture of 3 sigma. In this boundary we have a depth of 3 sigma. Okay, but now there is 6 sigma thing which is come into existence. So that means we are capturing all the length and breadth of the uncertainty, and then we can decide whether we can go from 2 sigma should be, or 6 sigma should be our range. When the dabbawalas can achieve 6 sigma level in nuclear plant in a selective basis, like say our plant core damage frequency, whether it is meeting 6 sigma level, yes, it is meeting, because the core damage frequency, if it is less than 3.6 into 10⁻⁶, we are meeting the service, because we are delivering power to population, and that we are ensuring high reliability. That is why when we say that nuclear plants sometimes they operate for more than 2 years continuously, that means we achieved Six Sigma goals. So, we have to systematically define that matrix, and this is going on as part of risk-based engineering. Data collection and analysis. How many data points are required to say that enough data is there? And if enough data is not there, what is to be done to justify our data, or how we should bring in that subjectivity of inadequate data, and with that we are presenting our result. And so, that is where you require quality characterization, So, every assessment will be with some subjective judgments or subjective discussions. So, this is one thing. So, now another thing is, if operational precursor events, and this particular operational precursor got vindicated by a new paradigm, it is called prognostics and health management. Prognostics and health management means, if I have a component, I will put a sensor here, and that sensor will feed the data to me. I will analyze those data using, first I will filter those data, okay, then analyze, and then I will predict the failure of the component along with the uncertainty bound. Okay. So, PHM is doing it, but you cannot apply PHM everywhere because it is very expensive, resource consuming. Okay. So, but then we can have a precursor monitoring system or a culture. Anything we found deviation in the plant, even in walk down and all, we can. So, how to define the precursor? Okay. So, the precursor can be defined as any warning ahead of actual failure, or trend, or event, or a parameter that predict the incipient scenario in advance, like a failure, or a component, or a event becoming a part of the accident sequence. To qualify further, accident precursors are those operational events or group of events, or even near miss events, factors including the human actions that has potential to or propagate to lead to unacceptable consequences. So, probably with these two definitions will clarify any signature that is giving a warning that there is a incipient failure and we have to correct. I gave you vibration on a pipeline or support, and then what we should do, whether we should shut down the plant, or we can shut down the plant in the, we do not have to shut down, but keep monitoring the plant. Bearing is the best example. Pump bearings, they are best example. If before the pump bearing fails, temperature start increasing, vibration start increasing. So, this is a signature from steady state, it is deviating and it is going to the higher level. Now, it is a plant management aspect or prognostics and health management component of a prognostics, that what action should be taken. It should be taken now or closely monitor it. If we can bring plant to shut down within half an hour or 1 hour, then we can say, okay, we will wait, we will have, half an hour is the action time we have. So, let it come to some acceptance level or some threshold level before we take an action. Fine. Now, how precursors are relevant in our risk conscious culture? It is a critical component. Especially not only from hardware, but from human metrics also. We are monitoring and that we call as performance of the one person and two persons, their performance level. If they are working with you, you will come to know that there are some precursor signatures are available, and sometimes precursor signature for even security also that are available. So, precursors are very important. Only thing is we have to have a high conscious approach to observation, monitoring and all that. Now, accident precursor is one of the major application of risk informed application. Mostly for precursor analysis, especially when we are talking about the accidents, the probabilistic risk assessment provides a very, very effective approach for evaluating the precursor, its potential, and what consequences it can cause. Okay. So, it provides a systematic framework actually. Surveillance, monitoring, inspection, management approach like, and many of these tools called precursor, they have already there. We do in-service inspection in the plant. Why we do? If any crack is incipient, or if it is vibration, pipeline is vibrating, or some corrosion phenomena has been monitored outside the plant. So, these are all signal of incipient failures. So, that is why in service inspection, condition monitoring, they are also part and parcel of precursor monitoring. Generally, PRA model provides an effective model for precursor analysis. So, PRA has got, that is the risk based approach, has got its role over here also. Now, how to evaluate human operational precursor? So, how error occurs? All of us we know, if there is a challenging situation or if the task is very complicated, then chances of error are more. So, in this simple one slide, I have tried to capture this phenomena. So, let us say we are developing a mathematical model. Okay. So, we know that risk means likelihood and consequences. So, that means we have to have two components. So, what is the likelihood that an operator will do error? So, before that, let us understand the job can be of three types. One is knowledge based type, which requires thinking, cognitive capability, and they are considered as one has to be very careful, and then you have to come to some inference ki what is going on in the plant. So, and the other one is rule based. That means if this happens and that happens, then I have to do this. So, they are not as complex as Q1. So, second level is Q2 and third level is skill based. I have to take the reading monitors, I will go and take the readings, I know the unit and everything, or if I am a welder, how the welding job has to be done, nobody should tell him, he knows. These are all skill based jobs. So, the risk levels are increases as we move from Q3 to Q1. Okay. And unlike the traditional paradigm in which either a job is considered as knowledge based or rule based or skill based. Okay. We analyze that job actually, but in risk based engineering we have E component here, and here we say a job can have Q1 component, Q2 component, Q3 component. It is quite possible that Q3 component is 0, it is not skill based, it is only, but then the weightage factors we give for all the three levels. Okay. And so, we say any job is a mix of, because even if it is a job in control room, often it tend to be skill based. I am monitoring a reading and I am operating a ball. It is skill based. There is no knowledge based. So, all the jobs in control room need not be knowledge based job. Okay. 90% job will be knowledge based job, but some can be. At the same time, if job is going on in the field, even if it is a simple job like a welder's job or some erection activities going on, they have to be very careful that it should not fail, otherwise it will lead to high consequences. So, here we have a collective coverage from Q1, Q2, knowledge based, rule based and skill based. That is one difference, and that is how this matrix has been defined, that is potential for precursor event. Okay. And here for human it is Jx is a job complexity factor. Okay. So, job complexity factor can be reflected by W1, Q1, W2, Q2 plus W3. We think all the components are there at fundamental level, but later on any thing weightage factor could be 0, 1, 0.1, 0.2, 0.3. Weightage factor varies from 0 to 1. So, that weightage can be given, and then we have event rate, event ER is the event rate here. Okay. So, Jx is complexity factor, event rate. We normally have a database where event rates are there, and that is either you can call reference or average event rate. So, that we can be, and then what is the time window? These are the reasons, how much time is available for us, and what is the time, how much time is required to complete a job, and what is the time window is available. Let us say I want to open a wall. Now, the time required is only 15 minutes, I have to go to the site and close it, and time available is, let us say, very large, 5 hours. So the probability of this ratio is there, probability of error will be risk is very low. Okay. And then the last factor is consequence factor, which we get from here. It depends on what are the consequences that are so it could be ranging from event into the emergency management here to event that might not have a local system or plant level consequences. It could be some minor thing. So it can be given better this factor consequence factor C. This table is for C. It can be 1, 2, 3. If it is at equipment level, we give 2. If it is at system level, that means system, it will affect the system adversely. If involves supervisory monitoring and logging diagnosis affecting, then, and that way the seriousness goes up as we go down actually. And these factors are used, and what you get, the expression of precursor risk potential. Whatever failure we were about, what is its risk potential, that can be evaluated. And finally, this is the final formulation over here for this, and I think this is a systematic way how we can evaluate the precursors. Role of human root cause analysis. You would have heard the word. This is again a part of enhanced component into the risk-based engineering. So I would say here also it is a E component. I am using for E component of risk-based engineering. Why? Root cause analysis is done for hardware component, software component. Why they are failing? And there also our discussion goes up to human root. And those human roots are normally, the human roots are like error of commission, error of omission, mistakes, faults, or lapses, and this kind of there are some numbers, the terms that are used here. But we have to ask ourselves, the E component in RBE, it asks us to why the human did the mistake. That is more important, and for that we should have a so if I have to talk about the E component in RBE, so first is identification of human roots involving why human error occurred, just I have mentioned, and then a deductive approach starts. What is happening at physiological level, psychological level, and where its root are there, whether it is in the plant or whether it is in the family, so that we can avoid those things. And then and often if it is in the plant, we need to do a simulator exercise, whether the time given was very less for that event for recovery, or is it that there are some problems with the component which was to be operated, directly putting it on as a human root will not serve any purpose. Like in aviation, if the pilot, what mistake he has done, if we do the human root cause analysis, it is quite possible we might land up into many of the organizational factors, point number 1. And then in those organizational factors, because there also organization means human, there also what mistakes have happened even at the organizational or man-machine interface level will have its own roots, and we have to go to those roots. What was the limitation? And that is point number 1. Point number 2, it becomes more serious matter if it is related to conscience, cognition and conscience. Okay. So this has come twice actually. It is consciousness actually. It is consciousness, cognition and conscience. If it is happening at this level, then probably, because these are deliberate, it is not error. So one has to be very, human root cause analysis is more important for security systems. Okay. So QA programs for human root cause analysis is required. Whether the root cause analysis we are doing, it is simply a brainstorming or it is serving a real purpose actually. Okay. Now for our plant, the risk model, it requires, so here we have to be very cultural, because the data reflect the risk model of the plant. So now if we have any compromise in data collection, data analysis, or lack of data, or not quality data. So first question comes is generic information. If I am developing my risk model based on only generic data, of course, in design stage there is no option. One has to use the generic data only. But then your analysis will be for the plant from where we are using the data. It will not be bringing in the intimate aspect of your plant. Okay. So there are ways out there actually. It's not there. So at design stage, okay, we can do. But as the plant comes into operation, this generic data should be in a systematic manner, should be replaced by plant specific data. This is one. Now, plant specific information, one note, observation, as far as possible, the plant specific data should be used in the plant. This one heuristic one should use. If it is not available, but for operating plant, there is no problem. Even if it is operated for 5 years or 10 years, we can have, at least for safety system, we can have those, because risk we are risk modeling we are doing. So for safety system, we will have those data. And combining, suppose if not adequate data is not available, this is one more situation where plant specific data is not adequate. Then there are Bayesian updating, and these tools are there where mathematical models are available. You can combine plant specific data with generic data. As our plant experience will start building, the generic data will lose its bias, and we'll have our quality of data will be better, and we will be going to the plant specific data, maybe 10, 15, whatever. And then many of the data, they are coming, especially in operational domain, they come in qualitative language. Like, let's say, what is your diesel generator failure probability? Operating staff will not give you a quantified answer. He will give you, it is low actually, or he will say it is medium, or it is very high. Now, how to interpret this information in our risk model? Because risk model requires quantified data. So, a fuzzy logic paradigm, it provides a very, very effective framework for transforming the linguistic variables on performance of component system or anything into through membership function. It gives the possibility of that component. So probability and possibility in the absence of the data or only quantities, it can be used just to see how it impacts the overall risk statement. Okay, and then regular updates and modelings are required. So this is, otherwise when we compromise as a culture, risk conscious culture, if we compromise on the data, then our risk model will be different or it will be weak, and if the risk model is weak, our risk conscious culture also will be very weak. So we introduce the risk model as part of RCC. Risk conscious culture we have discussed. Data and requirement, very important component, because if we compromise on data, then we have issues. Enhancement of risk, we have seen at two instances we have done. One is consideration of how failures will be there, and then how to pursue those failures, and then evaluation of risk potential. And then we saw that the biggest achievement was that we saw that risk model can provide all the answer, and the RAMS aspect can be considered as a residual RAMS aspect. Human precursor, which is a very important part of it, is almost like implementing a prognostics and health management, which is a very resource consuming exercise, but our awareness, our cognition, it can really double up for a PHM for rest of the plant. If I am going in my plant area and just keeping my focus, and I hear a noise which was not there till yesterday, and on my third visit it is increasing. So it is almost I am doing a prognostics, So and then I am taking action. So that failure will not occur. Thank you.